In this lesson, we're going to be solving trig equations. So to solve the equations, we're going to apply the trig identities to isolate the variables. Alright, so in this equation, we want to find all of the values for theta in the interval from 0 to 2 pi, including the 0. Alright, so the first thing that we need to do is, this appears to be a quadratic equation, so we want to set it up, bring everything over to one side, set it equal to 0, so that we can solve the quadratic equation, hopefully by factoring. If we factor that quadratic expression on the left side of the equation, we get tangent and tangent in the front of the parentheses. The only factors of 1 are 1 and 1. And the constant term is positive, so that tells us that both the signs are the same. The middle term is positive, that tells us that both signs are positive. And so we just set each one of those equal to 0. Since it's a double root, we can just set one of those factors equal to 0. We get tangent theta plus 1 equals 0. So when we subtract 1 from both sides, we get tangent theta equals -1. And on the unit circle, tangent equals -1 in the second quadrant and in the fourth quadrant. In the second quadrant, sine will be positive, but cosine will be negative. In the fourth quadrant, sine will be negative and cosine will be positive. Alright, so the 3 pi over 4 is the location, the degree measure in the second quadrant in radian, and the angle measure in radians in the fourth quadrant would be 7 pi over 4. All right, those are the 45-degree angles in the second and fourth quadrant. All right, for this one, we've got a half angle, so we're going to be using that half angle identity. First thing that I did was divide both sides by -2 to isolate that cosine of theta over 2. And then I can, I just change the sign. I divide the -1 into both of the terms in the numerator to get cosine theta plus 1 over 2. And then now I replace the cosine of theta over 2 with the half angle identity. I get the square root of 1 plus cosine theta over 2. And then I square both sides to get rid of the square root. Whenever I square both sides, I'll get the quantity cosine theta plus 1 squared in the numerator on the right side, and then 2 squared is just 4. And then from here, I'm going to multiply both sides by 2 to get rid of the 2 in the denominator on the left side. Once I multiply the right side by 2, the 2 will divide into 2 one time and into the 4 2 times, leaving me with the 2 in the denominator. And then I multiply both sides by 2 to get rid of the 2 in the denominator. That will give me 2 plus 2 cosine theta on the left side of the equation. And then now you can see that there's going to be another quadratic equation that's formed. Alright, so we've got the 2 cosine thetas, they both cancel. Since you have 2 cosine theta on both sides of the equation, and if you subtract 1 from both sides, you'll be left with 1 on the left side of the equation, and so that leaves you with cosine squared theta equals 1. Take the square root of both sides, and we get cosine of theta equals plus and minus 1. So cosine of 0 does equal 1, cosine of pi equals -1. And then this last example, we've got, we want to solve this equation. We want to solve for theta. First step, 4 sine theta equals 0 because we added 4 to both sides of the equation. And then divide both sides by 4. You get sine of theta equals 0. So sine equals 0 at theta equals 0 and at 180.